In this video, we're going to be talking about the law of sines. Now, the law of sines is actually really nice because it's one of those equations that's easy to memorize. It looks elegant. It's kind of like the Pythagorean theorem in its simplicity and its elegance. And believe it or not, mathematicians actually do consider those things when discussing math and when writing proofs. If you Google most beautiful math equation, there's generally a consensus on that, believe it or not. The Google hits will lead you to one specific equation. We'll talk about that in another video. But the law of sines is written like this, and it relates to triangles. And what's nice about this is, we used to be tied only to right triangles. Now we can use any type of triangle. So how this works is, you can label A, B, and C any which way. You can put A, B, or C anywhere you want. But once you label the angles with the capital letters, you have to label the sides with small letters and do it accordingly, where angle A is opposite from side A, angle C is opposite from side C, and angle B is opposite from side B. Alright. Once you set those up, what is it? Well, this is the side length, this is the angle measure. So this might be 17.2 feet, and this might be 33 degrees. Okay. The whole thing here is we're no longer tied to the 30, 60, 90 triangle. We can have any angle, and we can have any side length, and it'll work. So how does that work? Well, let's take another example, draw a new triangle that's not all drawn over, and we'll put in some numbers. Okay, so let's say we have a triangle here. Let's say A was, that's more than 90 degrees. Let's make that 95 degrees. Let's say this distance here, let's say we knew that was 10 miles, let's say. And we're trying to find this distance here, okay? We'll need one other piece of information in order to solve that, and then we can go. So let's say we actually also knew that the angle here was, let's put that at 41 degrees. Okay, so that's all we need. We need two angles and one side, or we need two sides and one angle. Either way, we'll have enough. Okay, so with this information, let's go ahead and set it up. So I encourage you to pause it right now and go ahead and set it up. Now, if you're stuck and you're waiting for me, well, let's see. What are we going to do? Well, we don't need all three parts of the triangle. We have parts for C, and we have parts for A. We don't have any of this, so we're just going to set up that part of the equation and pretend like that middle part just doesn't even exist. All right? Let's plug in what we know. We know little a is, oh, we don't know. We'll call it x. Call that x. Or actually, why create a new variable? Let's call it little a. There's no reason to call it anything else. Sine of 95 degrees, and then 10 over sine of 41. All right, that looks a little bit sloppy, I apologize. But when you get down to it, this is just a fraction problem. This is like having 1/2 equals 3 over x, okay? The way you get this is you cross multiply things. So that's what we're going to do here. We're going to cross multiply things, okay? A times sine 41 equals 10 times sine of 95. All right, and to get it all alone, we want A alone, that's what we're after. We're going to divide both sides by sine of 41. And those cancel. Okay, so over here we have 10 times sine of 95 divided by sine of 41. You still have to be careful when you put on the calculator, but that's the whole thing. The math here is not too tough. The calculator is going to do the hard work for you. We just have to make sure we set it up right, and then from there, cross-multiplying and doing this part, you've done this before. I guarantee it. All right. This part here, let's get out the calculator and, again, do the top part first, divide by the bottom part, and make sure you are in degrees this time on your calculator. Take a second, check that, and let's see what we get. All right, so on my calculator, I got about 15.18. And we'll just round it out to about 15.2. All right. And, again, when you look back at this, relationship-wise, yeah, this does look like it could be about 15.2. If we got something smaller than 10, we'd know something's wrong, okay? Since this is the 95, it's got to be bigger than the angle, the side that has a 41 across from it. Okay, so this is the biggest angle. This would have to be the biggest side. All right. Thanks for watching, and check you next time.